Find the derivative of the given function using the sum, difference, constant multiple rules. The derivative of the sum is the sum of the derivative. The derivative of the difference is the difference of the derivative. And when we have a constant multiple, we will simply rewrite it and multiply it whatever derivative that is followed. What that means is that if we have the sum or the difference in the function, we simply derive each term individually and then add or subtract them correspondingly. For part A, derivative f prime of x is, this is the sum, and so we will take the derivative of each terms separately and then add them. Derivative of x to the 0.5 using the power rule, we bring down 0.5 x and then we lower the power by 1. 0.5 minus 1 is negative 0.5 plus 2 in this case is the constant multiple, so we would rewrite it times whatever derivative that is followed here. Derivative of x to the negative 0.5, we bring the negative 0.5 to the front because this is power, and then x, and then we lower the power by 1. Negative 0.5 minus 1 is negative 1.5, and then we simplify this. This is 0.5, x to the negative 0.5. 2 times negative 0.5 is minus 1. And then we rewrite x to the negative 1.5. Usually we don't write negative 1, we just simply write negative if negative 1 is a constant multiple. So this is 0.5, x to the negative 0.5 power minus x to the negative 1.5 power. For part B, this is the sum and the difference, so we will take derivative term by term. G prime of x, derivative of x to the negative 2 using power rule is negative 2x, and we lower the power by 1. Negative 2 minus 1 is negative 3. Minus 3 times, this is the constant multiple. Derivative of x to the negative 1 is negative 1x, and we lower the power by 1. Negative 1 minus 1 is negative 2, plus derivative of 2, which is now a constant, not a constant multiple, but a constant. Derivative of a constant is 0. Then we simplify this. Negative 2x to the negative 3. Negative 3 times negative 1 is positive 3. X to the negative 2. For part C, h of x equals 1 over x minus 1 over x squared. Each of the terms are not in the power form yet, so we will still need to rewrite them before we find derivative. So this is not the derivative, but it is only the rewritten form. 1 over x can be rewritten at x to the negative 1 power. Minus 1 over x squared can be rewritten as negative x to the negative 2 power. These are now in the power form, so we would differentiate this. H prime of x is the derivative of x to the negative 1 is negative 1 x to the negative 2 minus, and then we bring down the power, which is negative 2x, and then we lower the power by 1. Negative 2 minus 1 is negative 3. And lastly, we simplify this. This is negative x to the negative 2 power. Negative times negative 2 is positive 2, x to the negative 3. In the previous example, we did not need to rewrite it using positive power, but in this case, we will need to, because in the previous example, the original problem was given to us in the negative power form, and so we would give them the answer in the negative power form. But in this case, the powers are positive, and so we would need to rewrite this. This is negative 1, and then x to the negative 2 can be rewritten as 1 over x squared plus 2 over x cubed. And again, this is the derivative. And lastly, first we rewrite this as k of x equals the absolute value of x minus the square root of x is x to the 1/2 power. There's a typo here. Plus minus is minus. This is the difference whose derivative is the difference of the derivative. So h prime of x equals the derivative of the absolute value of x is the absolute value of x over x minus the derivative of x to the 1/2 is 1 over 2x, and we lower 1/2 by 1, so we have negative 1 over 2. This is the absolute value of x over x minus 1 over 2x to the 1/2, or the absolute value of x over x minus 1 over 2 root x.